In this video we're going to look at a mechanics question involving a block on a slope, and if we read the question we see that this is a rough plane, so that means there's going to be friction involved. So the first part is to draw a diagram to show the forces acting on the block. So let's just, first of all, let's just draw the slope. We have a slope of 22 degrees. And we'll just draw the block as a pastoral first of all. We always model it as a pastoral rather than a block. Now what force is acting on the block? Well, we always have weight of the block which is acting vertically downwards, and weight is mg. So W is m, or the mass is 0.7. So this is 0.7 g acting downwards. We'll also have a reaction force which acts at right angles to the plane. So we're going to draw that in at right angles to the plane, and that is R. What else do we have? We have tension in the rope, and that's already drawn. So the tension, this is acting parallel to the plane in this case, so T is pulling up the plane. And finally, it's a rough slope, so we're going to have friction. Well, if we read carefully, we see the block is being pulled up the slope. Friction will work in the opposite direction to motion, and it will be parallel to the slope. Since the block's going up the slope, then friction will be going down the slope. So here's my F. This is my force diagram. Okay, let's have a look at part B. Show that the normal reaction has magnitude 6.36. Okay, so to do this, we're going to resolve forces perpendicular to the plane. And because the block isn't sort of sinking through the plane or flying off, that means forces perpendicular to the plane will be balanced. Well, what do we have? Well, we have sort of acting upwards out. We have R. So that's sort of if we take this up positive direction, so perpendicular to the plane but upwards. So R is a positive force, and negative force we have W. So mg. Let's see. Well, let's have a look at this. We should probably break down this weight into its components. So we can break down weight into two components, and the angle here is 22. So the two components are, well, the one component here, the one acting downwards, is 0.7 g cos 22. So R minus 0.7 g cos 22. Again, because this is not flying upwards or down into the plane, they're balanced, so this is 0. So that means that R equals 0.7 g cos 22. If we do that calculation, with g is 9.8, 0.7 times 9.8 times cos 22, that's 6.36 newtons. That's correct to 3SF, which is what we expected. Okay. Coefficient of friction between the block and the plane is 0.25. Find the magnitude of the frictional force acting on the block during the motion. Well, because we have motion, then F is at its maximum value, which is mu r. And we're told that mu is 0.25, so F is 0.25 r. So all we have to do is, we know what r is, so F is 0.25 times 6.36 is 1.59 newtons, again to 3SF.